Right, Yasmin, are you back with us? I think you'll join us shortly. We had a slight technical hitch. The calculator decided it was going to freeze on me and not work. So with the result, we've gone back to the good old-fashioned style calculator, one in my hands. So anyhow, at the stage till we get a link back, what I'm going to do is carry on using this little side calculator. I think by now you've all been around for such a long time, you're not worried about something small like a calculator. So what happens is we get a positively revolting answer. So in actual fact, once we have our caller back with us, I will congratulate. Ah, you're back. Good.
Yes, ma'am.
Your instinct to go with the formula was excellent because this thing did not factorize.
Oh,
so
okay.
you would have sat for ages trying to factorize it and got absolutely nowhere. So on the bright side, you actually are able to now use this calculator. So now I'm using the good old hand version of this, and I'm just going to go up and edit since I've got the option to do that. And I'm sure you've got your calculator with you as well, so you know what's going on. Right, I'm just going to space bar through it and just change the E to the minus sign, assuming it will let me do that. Okay, and it's going to delete, and I'm going to put in a minus, and I'm going to press equals, and we're going to get another hideous answer. Now, hopefully, in somewhere in this question, they said to so many decimal places, or if they're on the front cover, they must have said something like that.
Correct, 2 decimal places.
2 decimal places, fabulous. So let's have a look at it. So we've got x equals 1 comma, and if we're going to go to 2 decimal places, that 6 will change that to a 9.
All right.
And over here, x is equal to minus 1 comma, and again, 2 decimal places, that 3 won't change that, so it will stay 80. So you can see that the turning points you are getting are not pretty ones at all. Now going back to our drawing, this one must be the minus 1 comma 8 something. And the other one, I can't even remember what it was 39. So that's
1 comma 39.
1 comma 39. Now obviously they want the coordinates of A and B, so we need to still go back and find the Y value. And this is where we're ever so grateful for the calculator yet again. It's just a pity I can't show you on the calculator on screen. But as I say, you guys are a trick. I'm sure you're okay with that. Right, so now we go to the original equation, which I've just realized is up there. So it's 4x y equals 4x cubed. I think it was minus 27x squared.
Plus 27x squared.
Plus 27x squared. And the rest of it?
Minus 30x.
Yes.
Minus 1.
Minus 1. Perfect. So now what I'm going to do is I'm going to use the calculator with this. Now, a clever move on most of the calculators is to go 1.39 and then press your equals button, which puts it in as the answer. Now it would just be a matter of using answer every time you see an x. So we'd go 4 times the answer cubed plus 27 times the answer squared minus 30 times the answer minus 1. And the y value that's going to work out here is 20,209176. We'll come down to the rounding just now. And over here on this one, we're going to do the same thing. We're going to key in minus 1.8, and I'm going to press my equals button, so now it's in the memory. And now we'll just go 4 times the answer cubed plus 27 times the answer squared minus 30 times the answer minus 1 equals, and we're going to get a decimal answer of 117,152.
Yes, ma'am.
Okay, so does that look like you could be right there? We'll look at the drawing in a minute. That's also very important. However, they said we must give it to 2 decimal places. So over here, that 9 will change that to 2, 1. So we have a coordinate 1. Oops, I just used the wrong thing there. Let's go back here. We have 1,39 with 20,21 is the one coordinate, and the other coordinate minus 1,80 and 117, and again, if we're going to do 2 places, it's going to be 15 like that. Now let's go and look at the drawing. It does make sense that this would be quite a large number. Looking at that, that's cutting at minus 1, as we know from the drawings. And then over here we've got the 139, and I think it was with 20,21. Now that looks like there's an error there, because why do I know I'm wrong? Well, if I look at this drawing, that can't be a positive, can it?
No, ma'am. Yeah.
No. So that means I need to just go back and check that substitution of 1,39 and make sure I didn't do something silly on that. But if we can't get it, it's fine. We'll just improvise and use this. Let me just put it equal. Oh, okay. I think I know what I have done. Yes, here we go. That's why we're getting such a hideous answer. I do apologize. Over here it is actually 54 and not 5. So that was very bad of me. So you know what? I'm going to have to redo this from that point. I do apologize. Yasmin, I've probably scared you senseless with all these things. But however, notice that even if I had done that, so if I was in the exam and I had done that, they would have marked it through because it wasn't making the question easier. It was actually making the question more difficult. I hope.
Right.
It still might require the actual thing. So let's go back here, and I think it was very careless of me. This should have been a 54, not a 5.
5. All right, ma'am.
So that might be easier to factorize as well, but we'll just put it into the calculator since we over here, and I think it was minus 30. All right, so all that'll happen is this is a 54, and this is a 54, and hopefully it's going to give us better answers than what we got last time. So we don't have to do all this hectic arithmetic. So I do apologize for that mistake. You must watch me and shout if you see me do something like that again. Yes, just keep your eye on me. All right, so let's have a look at it. I'm just going to put it in the calculator for convenience.
All right.
It's minus 54. It probably does factorize quite nicely, actually, I would guess now, looking at it. Okay. Now, I believe we can say thank you to a learner who called in and had picked up that I had transcribed my number incorrectly. Oh, yes, this is an absolute pleasure now. So thank you to that learner, whoever it was. It's a nice, easy answer now. You see the difference. Look how nice that is. And then if we go back up there, I should imagine the other one's going to be equally easy. Unfortunately, that was a careless slip on my part. So thank you to that learner. Just shows you everybody can make a mistake, even the teachers. In fact, mostly the teachers, because I think we do more of it, so we have a lot more exposure. Right, so let's just delete that one sign, make it a minus, and it's going to be a nice factorization as well. So many thanks to the person who called in. It is, oops.
Minus 5.
Yeah, what did you get as an answer there?
Minus 5.
Minus 5. Thank you. I pressed the wrong button, obviously. Okay, so we're not having a good calculator day. All right, so now that's infinitely better. So yes, there would have been nothing wrong with that really, because your calculator does that calculation for you, and it would have saved a lot of trouble. And of course, if I hadn't made a mistake, I probably would have got the factors very easily by just using the original. Right, so now we go back for the y values, and I don't know if we should, yeah, let's just quickly get them. It was what, 4x cubed plus, was it? Or
Plus 27x squared.
27x squared.
Minus 30x.
Minus 1.
Minus
Okay.
1.
And I'm going to, again, use the calculator to make it a little bit easier. So I would go 0.5 and I'd put it equal. So it's now my answer. And now I can just go straight to it. So it's 4 times the answer cubed plus 27 times the answer squared minus 30 times the answer minus 1 equals. Okay, which gives you minus 35 over 4. Still not very nice numbers, but certainly better than they were.
Yes, ma'am.
And over here, if we take the minus 5, and we again do it, so we're going to say 4 times the answer cubed plus 27 times the answer squared minus 30 times the answer minus 1. And a delightful answer as well, 324. So we are getting some pretty huge numbers, but now this time I can see I'm correct.
Yes,
so that's why it's a very good habit to always look back at your drawing and see if the answer you are getting is possible. So the moment I saw it wasn't possible, I knew there had to be a mistake somewhere. And fortunately for me, a viewer had spotted it and phoned it in, and I knew exactly where I had made the mistake.
All right.
So it's a half with negative 35 over 4. So let's just change this. And now you can see that's much more feasible. A half with negative 35 over 4.
Right.
And the other one was negative 5 with 324.
Yes, ma'am.
Okay, so negative 5 with 324. And of course, it's not drawn to scale, so it doesn't matter that that looks unproportional. It isn't an issue. Right, so that was the first one, but I can see why you didn't like it. That was a nasty factorization that could have made your life, or did make my life, very difficult. Okay, now I'm just going to quickly mention how we go about the next question, because that isn't what you're calling in about, but I'm sure that people would like to know something about average gradient. Basically, average gradient is the gradient of the line passing through those 2 points. So literally, if I was asked to find the average gradient of the line through AB, let's just get a line through AB first of all. Let's put a nice green one in there. Okay, so what I would do then is I would go along and I'd say, okay, fine. We take the coordinate minus 5 with 324, and the coordinate a half with negative 35 over 4, and we calculate the gradient of that line. So we'd say average gradient is y2 minus y1 over x2 minus x1, and we would work that out. That would be average gradient. But that wasn't your question, but just for those of you that are interested in how that would be done, that would be the easiest way. There is a formula as well which makes it much more difficult. Right, then number 3 says C is the y-intercept. Determine the equation of the tangent at C. Now number 3 I have to do properly in order to do number 4, which is what you want to know about. So I'm going to have a look at this now. It says C is the y-intercept, so we know the y-intercept is where x equals 0. And I'd already written it in because from the equation I know that this has to be 0, negative 1.
All right.
So now what I have to do is I have to find the gradient of the tangent at that point. So if we're going to do this, let's take this green line that I had put in for the, if it'll let me select, it doesn't seem to want to let me select, so let's try again over here. Yes, there you go. Let's just get rid of it. Cut, and let's put in another one. So let's go to another line, and this time what I want is a tangent to the curve. So that means it would go like this, and it would touch at one point. And I can see I didn't do a very good job of drawing it, so let's just pull this in a bit. That's pretty much like that. So it would go, and it would probably cut somewhere else again. It wouldn't cut this part of the graph again, but if you look here, this line extended would probably cut somewhere up there. So let's have a look at how we're going to find that. So we have to first of all find the equation of the tangent. So I'm just going to get some space for us here. And to do that, we've got the gradient function over there, or the gradient, which is the derivative. And we want to know what is going to happen at 0, because the coordinate of C is 0, negative 1. So we want to replace every x with 0, so we're going to get a gradient of minus 30. That's why that line looks so scary. It's like quite steep.
All right.
So your gradient is minus 30, and then we could use the formula y minus y1 equals gradient x minus x1,
Okay.
or if you prefer, the y equals mx plus c formula. So let's use this one because I suspect most people would have used that one. So
Yes,
you would go y is equal to minus 30x, and the c value would have been minus 1. Now this is where your question kicks in, so I'm just going to get rid of the working we've got down here to carry on your question. Now your question says to me, determine the coordinates of the point on F where the tangent cuts the graph again. Now as I said to you, it's a very steep line. Maybe I should actually make it pink so we can see it more clearly. It would go like this sort of thing. It's a kind of steep line, very skew line, but it'll do. It's cut here. In fact, it's tangential here. And here somewhere it's going to cut. Of course, this is not drawn to scale, so we can't be sure of that point.
All right.
But we know that if this is tangential, that solution will actually occur twice. So what does that mean? What we want to do is find out where these two graphs intersect each other. So we're going to take this one with our original graph, which is 4x cubed plus 27x squared minus 30x minus 1. At last I know it off by heart. We're going to call this equation 1, we're going to call this equation 2, and we're going to substitute the one equation into the other. So substitute 1 in 2. And the moment we do that, I just need to get rid of this working because we don't need that anymore. Let's decided not to just help me out and go. There you go, it's gone. So what I'm going to do is I'm going to say, right, that means that minus 30x minus 1 is equal to 4x cubed plus 27x squared minus 30x minus 1. Now the good news is that minus 1 and that minus 1 will actually counteract each other.
All right.
So we're going to get 4x cubed. Bringing this over, we're going to have plus 27x squared. And again, this will counteract that one. So now what we're going to do is we're just going to take out the x squared, and that's going to give me 4x plus 27. We know that x is 0 is the C point. So if we look back to our C point, I don't know where I put it, but I know C was 0, negative 1.
Yes, ma'am.
So we know that happens, and what I'm saying to you is that will occur twice, which it does, x squared, or x is equal to minus 27 over 4. And that would be your other one.
Okay, okay.
So now what you would do is you would take this x value and substitute it back into either of the equations, actually. So definitely it would be better to go back to the straight line equation, which is y equals minus 30x minus 1.
All right, ma'am.
Which is nice and straightforward. In fact, I don't even think I need to do that with you. I think you'll be fine from here.
Yes.
So all I want you to remember about this is when they talk about things being tangents, whatever happens, so say I've got a curve like this with one like this, oh, bad draw, there, and I know that this value is 3. Then
Right.
I know that if I substituted these equations in and I got an ax cubed plus a bx squared plus a cx plus a d equals 0, I know that there would be a bracket that says x minus 3 twice. And so the third bracket would be relatively easy to find either by substitution and a remainder and factor theorem or whatever, or even calculator, or by inspection. And that's the one I would do. I would look at it and say, right, let's make sure I'm going to get this by putting it in there, and let's make sure I get this by timesing those together. So it's just a fact that if they are tangents, they repeat twice. You know where it ties in very nicely? I'm probably going into add break, which is very bad of me. But if this was 1, and we wanted to find its equation, do you agree with me we would go y is equal to a, x minus p all squared plus q. This would be your p and your q. And in actual fact, what happens is you get this happening. The q falls away, and that bracket repeats twice because this axis is tangential to it. So whenever it's a tangent, that bracket will recur twice, and that's why over here we've got the x squared, so x equals 0 twice.
All right.
Okay, so hopefully that helps you. So just remember that's a quick way to get out of it. This one was okay because once you got that, it was an easy, straightforward linear to get hold of. But it could have been a little bit more difficult, which you would have had to maybe use a bit of remainder and factor theorem on. Nia, thank you so much for calling in. There are lots of questions on cubic equations, and we'll see you all after the break.
All right, thank you so much, ma'am. Bye.
Thank you. It's a pleasure. Good luck for tomorrow.
Oh.
Thank you. Good luck. Speak to you all in shortly when we've had our break.